So we continue our work in section 7.2. This will be part 2 of the lesson. And the work here is not going to change radically until we get to the division. And even when we do the division, there's only one additional step that's required in that work. The name of the game in this work is factoring. You have to know many types of factoring, and you should feel comfortable and proficient in that factoring. If you don't, you will see posted later this week multiple videos on different types of factoring that you need to be proficient and comfortable in. During class also, beginning on Wednesday, January 22nd, had to think about that, you will have opportunities to begin looking at these in class and small groups, and I will assist in helping students to refine their factoring skills so that they will be very strong in this so that they can be successful in their work in Chapter 7. Let's go forward then. We did problem 23 last time. We're going to go ahead and do problem 27. This one is going to have quite a bit of factoring in it. So here we go. So this is going to be the quantity of t squared plus 2t minus 3 over t squared plus 4t minus 5 times t squared minus 3t minus 10 over t squared plus 5t plus 6. So those of you who are proficient in factoring may recognize pretty quickly that when looking at all of these trinomials, there is no greatest common factor. However, the one type of factor that you must always look for first to be present in the problem is the greatest common factor. Not seeing this here, we recognize that we have trinomials, and all of these trinomials are going to be factored into two binomials. So I will go ahead and I'm going to rewrite what the trinomials in factored form into two binomials, what these are going to look like. So let's take them one by one. We have t to the second plus 2t minus 3. Well, there's only one way to get t squared, and that's t times t. We're looking for two numbers that have a product of negative 3 and a sum of 2. Well, again, because this is a negative 3, one number must be positive and one must be negative. So since they'll be opposite signs, we want the numbers to have a sum of or product of negative 3 and a sum of positive 2. This can only be done by taking positive 3 times negative 1. For t squared plus 4t minus 5. The only two numbers that will give us a product of 5 are 1 and 5. The question is, what signs do we give them? Because it's negative, one will be positive, one will be negative. We also need a sum of positive 4. We only get that with a positive 5 and a negative 1. These two numbers multiply the negative 5, but add the positive 4. Again, t squared is obtained by t times t. Now we're looking for two numbers that have a product of negative 10, but a sum of negative 3. So product of negative 10, sum of negative 3. So they're going to be different signs. And the only two numbers that give me this will be negative 5 and positive, not 3, positive 2. Positive 2. Just checking to see if you're awake out there. And for the last problem, this one's a nice one, because here we're looking for two numbers that have a product of 6 and a sum of 5, plus 2 and plus 3. So now we have all four trinomials factored. This again is something that you should be proficient and comfortable factoring these trinomials in this way. Again, if you need more practice with this, then it will soon be offered to you so you can become comfortable. So let's take a look at the factors that are in common so we can look at what we can reduce. We have t plus 3. Here we have t minus 1. Here we have t plus 2. And so we have just one pair of binomials left on the top and the bottom. And this is going to be t minus 5. And we'll have that over t plus 5. Again, because there's nothing else multiplying the binomial that's outside on the top or on the bottom, we don't need to keep the parentheses on these. You may show that in your work. I would not grade you incorrectly for it, but just so you know, if you see an answer written in this form, it won't be expected to keep the parentheses. Additionally, when working in MyMathLab. If you have this type of answer, sometimes the program can be fussy and may not recognize this as a correct answer if you put parentheses with it. There's nothing wrong with it necessarily, but sometimes MyMathLab can be fussy about notation. So let's continue forward with some more challenging questions to see what kind of techniques we can bring with this one. Let's go ahead to question 35. This is going to be 7a minus 14 over 4 minus a squared times 5a squared plus 6a plus 1 over 35a plus 7. So in this one we have multiple types of factoring being represented. And we're going to take a look at a little bit of a different technique for this. Because this one, the difficulty with this question is that the coefficient, which we usually call the a coefficient, the number in front of the squared term, or the squared variable, is greater than 1. So it will not be quite so easy to show the factors for this. Okay. But let's take a look at the other factors first and see what we can get. The first type of factoring you always look for is the greatest common factor. And that will be, we'll be able to utilize that for a couple of these. For example, for 7a minus 14, I can factor out a 7 and write that as a minus 2. For 35a plus 7, I should be able to factor out 7 out of that and get 5a plus 1. Now for 4 minus a squared and for 5a squared plus 6a plus 1, there are no more common factors to, or no more greatest common factors to factor from this. But let's look at 4 minus a squared first. So here we have 4, which is a perfect square, and a squared, which is a perfect square, and we have the difference of them. So we're going to go ahead and factor these as 2, which is the square root of 4, a, which is the square root of a squared, and then plus and minus. Let's take a look at what we have here. Now, sometimes when you're factoring something like this, you can look at the factors at the bottom and see maybe this is one of the factors on the top. We're going to take a look at a different technique with this a little later, and definitely we'll take a look at how to factor these in a more consistent basis for the purpose of doing them later, but not for this specific example. So I see 5a plus 1 here. Boy, you know, I think that may be a factor here. So let's take a look at what I would need over here to get 5a squared. 5a times what will give me 5a squared? It should be 5a times a. Let's take a look at the other part now. What times what? 1 times what will give me 1? Should be just 1. Let's go ahead and check to see if these two numbers multiply out to this trinomial. So we'll have 5a plus 1 times a plus 1. I'm going to go ahead and multiply the outside here. So 5a times a will give me 5a squared. 1 times 1 is going to give me plus 1. Doing the inner now, 1 times a will give me plus a. 5a times 1 will give me plus 5a. A plus 5a, that gives me 6a. And since I get back the original trinomial, I know I have the correct pair of factors in this stage of the problem. So this is one way that you can check your work. So at this point we have all the factoring done. Let's see what reduces. First, we have 7s that will reduce in the problem. We also have 5a plus 1. That's going to reduce. We have, let's see, a plus 1. No, that doesn't seem to work. But when you look at the a minus 2 and the 2 minus a, you recall from the previous lesson in 7.1, when we had this kind of relationship of a minus b over b minus a, these will reduce, but they reduce to a negative 1. Now, you may show this as a negative 1 or simply keep a negative on the outside here. So there's a couple ways to express the final answer that we're going to get. One way is we can leave it as a negative outside the parenthesis of what remains, which is a plus 1. And that's going to be over what is at the bottom, which is 2 plus a. Another way, depending on if you're doing a multiple choice test or just looking for one way to express the answer, you can distribute the negative through the top, so it is written as negative a minus 1 over 2 plus a. I would accept this form fine. You may also even see it written as the negative simply being left in the center, and then a plus 1 over 2 plus a. So there's a few different ways to express your answer for this question. I would accept all forms of these answers because these are all mathematically equivalent. But again, as you're working with MyMathLab, sometimes it can be fussy about the notation. If you come across this as a problem when you're working at home on your homework, please bring these questions back to class so that we can discuss these further to improve your understanding.